Welcome to the next video in the systems programming video series. We are now done with reading the reading assignment for week 4, and I'm only just now realizing that I covered way more reading than we needed for this particular week. Maybe it was fine. I mean, it's all out of chapter 4, so it's thematically kind of sensible to just march right through it. But that does mean that maybe next week we won't be talking about any reading assignments, and we'll get straight into the assignment. Anyway, so we are now getting into assignment 3. The first thing in assignment 3 is this magic square assignment. So the instructions say to implement a program magic square.c that tests whether a given matrix is a magic square. A magic square is an n by n matrix where each row and column and diagonal has the same sum called the magic constant. Down here we see an example. So here's just how you make the file, which is kind of nothing new. This is worth noticing that there are going to be these text files, and so we are going to redirect, as we discussed in one of the earlier videos, calling like executing the program and giving it this command line sort of left arrowhead and then a text file that basically redirects the standard in to the text file. So rather than whenever we call, for instance, scanf, rather than that being grabbed from the terminal. Instead, it's going to sort of behave very much the same, but it's going to grab the actual inputs from the text file. Let's go look at the text file just so that we know roughly what it looks like. So here's an example text file. The very first line is a declaration of, the dimensions of the data. In this case, 3 by 3, because it has 3 rows and 3 columns. This is a standard practice, especially when programming in C, is to have your input file have some kind of header data that helps you to process the actual data after the header. So anyway, so we'll see how to use that in a minute. But let's just do a quick sort of check that this is a magic square. And I guess maybe we could come back over here. And the matrix is printed here. So let's look at what it says. It says that this is a magic square and its magic constant is 15. So why is it 15? Well, if we take this first row, sum across, 8 plus 1 is 9, 9 plus 6 is 15. So that's the magic constant. Okay, let's do it again along the next row. So 5 and 3 is 8, 8 and 7 is again 15. 4 and 9 is 13, and then plus 2 is 15. Okay, now let's go column-wise, right? So if we did 8 and 3, that's 11, plus 4 is 15. 1 and 5 is 6, 6 and 9 is 15, 6 and 7 is 13, 13 and 2 is 15. Now let's go along the diagonal, right? So this 8 and then 5 and then 2, that's the diagonal. And so 8 plus 5 is 13 plus 2 is 15. Let's now do the other diagonal. So that's going to go from bottom left to top right, and that's 4 plus 5 is 9, 9 plus 6 is 15. So you can see that along every row and along every column and along both diagonals, the sum is this magic constant 15. This one it says is not a magic square, so let's see why it is not a magic square. Let's sum along the first row. And so if we do, we get 16. Now let's sum along the second row, and if we do, we get 15, which is different. So this is not a magic square. Any square of size 1 by 1, which is what this is, right? So it looks like when we go to Magic 3, if we pull open that text file, we see that this is a 1 by 1 matrix, and the only entry is the value 1. Any 1 by 1 matrix is always going to be a magic square because the row sum in this case is going to be 1, the column sum is going to be 1, there aren't any other rows or columns to consider, so they're both 1, the diagonals are all 1, right? They sum to 1 in a very trivial sense. So anyway, any 1 by 1 matrix is always going to be a magic square. So anyway, so it's kind of a trivial check, but it's worth thinking about. So anyway, okay, let's look at the requirements. So we're going to read the matrix from standard in, as I described above, using scanf. The first two values are the dimensions of the matrix, which we've seen already. All subsequent entries, integers are the values of the matrix. Use malloc and free to allocate a 2D array to store the inputs. Okay, so that is the description of the assignment. Let's come over and solve it. Now, I solved it in advance. So if you want, you can sort of read here and see what I did to solve it, right? So I always want to start off just showing you a solution. Now, I do want to warn you that I think this solution may not be correct. Although maybe it is. Yeah, maybe it is. Actually, I was a little worried about whether or not this call to scanf doing just %d to grab each integer in the text file, basically. I was worried that that might not grab two-digit numbers. So like if we look down here in 5 or maybe even 4, this has two-digit numbers. And so I was, at least for a moment, worried that this might not grab two-digit numbers. It might only grab a single digit at a time and mess up the data. But in fact, I think this is actually correct. I think this will grab two-digit data values. So I think it's fine. I think, well, at the very least, though, even if that's not wrong, I do know that I'm going to want to make slightly different decisions than what I made here about how to pull the data in. Effectively, I don't want to make this variable cell when, on second thought, I don't need to create this separate variable. I could just throw the data values directly into the matrix. So in any case, okay, anyway, just here's the solution. If you want to see the solution, there it is. But now I'm going to comment it all out and build it from scratch. Okay, first things first, I need to read in a line from the text file, which is going to come in through standard in, which means that I just grab it using scanf. But before I do that, I need to have memory allocated to receive that data. So I'm going to declare int mn, right? So two integers. One m is for the number of rows, and n the number of columns. Okay. Now we'll call scanf. Grab. Now, if you remember how that row was formatted, it was two integers separated by a space. So if I just do that, and then here I put the address of m and the address of n, then that should grab, right, put into m the first integer, put into n the second integer. So that's my row number and column number. Having done that, I think I am now ready to grab the rest of the data, which is going to be on the subsequent lines. You know, the way that scanf works is now that it's grabbed the first line, the next time I call scanf, it's going to grab the second line and so on. And so let's do a double for, or actually, before I do a loop, I want to allocate space for the matrix. So let's say that this integer matrix, maybe call it matrix, equals, I'm going to malloc enough space for integers and m times n of them. Of course, I could, right, because in principle, it should be that m and n are always the same. Maybe I should even check that. And if it's not true, then I should like throw an error or something like that. That's a bunch of smart defensive programming, but I'm too lazy to do it right now. This is, you know, not a real industrial application, so I'm not going to take it that seriously. But anyway, if I were taking it super seriously, I would do that anyway. Okay, so let's now populate the matrix with the data from the text file. So I'm going to do a double for loop for int I equals 0, I less than m, I plus plus. And this is going to iterate over the rows. I will now want to also iterate over the columns. Now I want to grab the data. So let's say that in the matrix, at coordinate, now keep in mind that I have malloc the whole thing, right? So I am doing a particular strategy, which is not the strategy that everybody prefers when dealing with matrices or two-dimensional arrays. But this is the strategy I like, just because I know that at the hardware level, it's kind of efficient. And it, you know, in my personal taste, it's not that hard to manage the indices. So especially in a setting like this where things aren't that bad, I'm just going to do it this way, which is somewhat choosing the hard way, but I don't think it's too hard. So anyway, that's personal taste. You don't have to do it this way. Anyway, so I'm going to do I times n plus j. That is generally when you use this strategy For malloking your two-dimensional array, you need to say that when I am at row I, with I starting at 0, then I times n is the number of coordinates that I am skipping over to reach the row, and then j is the number of coordinates I'm skipping over, again, j starting from 0, such that I reach the coordinate that corresponds to what I want in the matrix. So anyway, this is how you get row I, column j when you sort of do a dynamically allocated two-dimensional array in the way that I am doing it here. Okay, and we need to get the data. This is not the right way to get the data because the data is going to come in through scanf. So we need to scanf, say that I'm going to grab, and by the way, I probably should do %d with a space so that it knows that spaces are delimiting these integers. That may or may not be necessary, I'm not sure, but we'll test it in a minute and see whether it is correct. I'm not going to be terribly interested to know whether or not I did it. If I left the space out, would it still be correct? I don't know. But I think this is correct, so we're going to run with it. But we're going to test it in a minute. Because, after all, you don't want to do too much work, only to realize that way early on, you had a mistake and you could have fixed it, and that could have helped you to design everything else correctly. So let's not write too much and then test. Let's write a little and test a little and write a little and test a little, right? That's a better pattern of development. So now that I've written this much, which is a little, let's go ahead and test it. And in order to test it, I just want to print out the matrix, right? Just make sure that the matrix makes sense. So let's go ahead and say that we'll make another double for loop and print out all the coordinates of the array that I've built. And I know that m and n should in principle be equal, but I just like using them separately. I don't know, maybe it's practice for when they could be different or whatever, but that's my tendency. Anyway, and so for each one of these, I want to print. And they're going to come from the matrix. I want row breaks, so let's say printf/n on every traversal of a single row is effectively what that's saying. Let's save it. Let's build it. Make magic square. Okay, so do that. Oh, right. It doesn't like this with scanf, right? Because I'm supposed to give it an address. Now, typically you think that, arrays kind of are addresses. I think that's probably why I made this mistake, is because in my head, I at least somewhat think matrices, or really any array, is basically an address to the data. But that's not really true. When you index it, it actually returns the integer, not the address to the integer. So I should make, this an address, right? So take the matrix at this coordinate, return its address, and that can get filled by scanf. So I think that's correct. So let's do that now, and let's run. So do this again. Now it builds. Now let's run it, and let's begin with running it on magic square 1. There it is. There's the matrix. I think we even recognize it from earlier, but we could click over here and be like, yep, that sure is the matrix. Let's run it on matrix 4 and see that it correctly recognizes double-digit numbers, and it does. So that's great. Okay, so things are going well so far. So now, what do I want to do next? I want to check to see whether or not it's a magic square. I need to store its sort of constant, the square constant. I think I'm gonna put, where do I want to put it? I could just put it in m and n, but I don't know. Why not just make some extra variables? It's not that much space. I'm probably being like wildly parsimonious with space when I think about things like that. But I should just be like, a couple ints is nothing. So anyway, so let's make some ints for the magic constant. And in fact, I know that as I go through this, like on the first pass, on the first row, I want to gather the magic constant. But then on the second pass, I want some other variable to figure out what was there, and then compare it against the magic constant that I found in the first row, and then do it again for the next row and the next row until the end, and then continue using it for the for the rest of everything that we check throughout the entire array. So I'm going to need two variables. So why don't I just go ahead and declare both variables now? So let's just say int mag const. So that's my magic constant. I'm going to collect that on the first row. And then on every other part of the matrix, all the other rows, all the other columns, both of the diagonals, I'm going to check against the value that we put here. So I'm going to initialize that to 0, and then I'm also going to make another value that I'm going to use on row 2 and after and so on, which I guess we'll call check, and check it against to see whether or not it equals the magic constant. They're initialized to 0, but they're going to get updated. So okay, so let's check every single row. So for int I equals 0, I less than m, I plus plus. This is going to iterate over all of the row indices. For int j equals 0, j less than n, j plus plus. This is doing the row-wise check, right? Because you pick a row, and then along that row, you build, right? You check each column value, right? So this is a row-wise check. Fix the row, progress through the column values. So, okay, on the first row, I'd like to, decide what the magic constant is. And how do I want to do that? Honestly, should I maybe, I don't know, how do I do? I mean, I could put an if check here. It's simple enough. Let's just do it. Like, I'm probably like just way too overthinking this simple assignment. So, okay, so if I is 0, then let's go ahead and build up the magic constant. So that's going to be mag const plus equals what I find in the array, which is going to be matrix at I n plus j. And if it's not I equal to 0, then I would like to find whether or not the magic constant that I found is, honestly, I can spot sort of logical flaws in developing it this way. Tell you what I really should do is just figure out the magic constant on a first pass and then proceed with a check at every row. If I don't do it that way, it'll be messy, or it might even be logically wrong. So let's just do it that way. Let's just come up here that I am gonna, and let's, not that this matters, but I'm gonna say j, and it's gonna go up to n, and I'm gonna increment j, and I'm just gonna do this on row 0. And so what I'm gonna say is mag const plus equals matrix at j. So that's just gonna traverse the first row only and build up the magic constant. Now that the magic constant is done, let's now traverse every row. So here I'm going to put traverse each row. And let's say for int I equals 0, I less than m, I plus plus. For int j equal to 0, j up to n, j plus plus. Now I'm gonna, right, the point of this is to go one row at a time, build up the check value from each row, and check that it's, the check value comes out equal to the mag const, and then when the row check is done, we'll zero out the check value. So, in fact, it might even just make more sense to make every initialization equal to 0 here. It's a nice way to just see that, yeah, when you do it that way, there's no doubt that check is equal to 0 every time you start a row. Not that I have to do it this way, right? I could have left the initialization up there, but it's just more visible when you write it this way. So that's nice. Okay, anyway. So then we're going to say that check plus equals the matrix at row I, column j. And then when we are done with the row, which is what happens here, then we want to check to see whether or not the check is equal to the mag const. If they are not, then I want to set an indicator telling me, I mean, I could break for one thing, but I also want to, set an indicator telling me that it's not a magic square. And so what that kind of means, right, because like as soon as I find a single counter example, then I would like to set my indicator to false and then it could never become true again. Well, you know, with any kind of design like that, then what you kind of want, I'm going to make a Boolean value, but C doesn't have Boolean values. So I'm going to make an integer, but the integer is going to be sort of coded by me to be 0 if the data is a magic square and 1, or sorry, other way around. 0 if it's not a magic square, 1 if it is mag initialized to true, right? So the idea when you're designing things this way is that if you see a single counter example, you're going to set it to false. Well, then it must be initialized to true and then is waiting for a counter example. So that's why I'm doing that. And so when the row sum is done, and I can now do my comparison, I'll say if mag const, let's say not equals, in fact, actually, yeah, let's say if, there's probably a more elegant way to do this, but let's just say if mag const is not check, then I would like to set isMag to 0. There is a better, I mean, not that it super matters, but you know, like when you don't have to do something with an if, it's nice to do it in one line, not using an if. So I think actually, couldn't I just get the same result by saying mag const times equals, because remember these are integers. Or actually, let's just say, actually, maybe could I say and equals? Yeah, that's probably better to use the logical operator and then say that, what was it, mag const double equals check. So that's probably a nice, right? Like that's a one-line thing. You're not using an if. It might be a little bit harder to read and a little bit harder to think about when you're first getting used to designing things this way, but it's a little elegant, and when you get used to it, maybe you like it better. So anyway, I'm going to do it that way. Looks like we have our row check done now. And right, and I could break out, but I don't know. I mean, is it worth putting a break command? I'm not going to bother. But what I do want to do is say that, like, you know, if not mag isMag, right? So by now, isMag is a Boolean value true or false, and I could say if it is not a magic square, so far only having done the row check, we'll get to the others later, but I could go ahead and start writing this part and say if it is not a magic square by right, like from the checks that we've performed by now, then let's go ahead and print fm is not a magic square. And I guess that's the end of that, right? So there we have it. So this should return true for magic1, the .txt file, magic1, because all of its rows sum to the same value. It should return false for magic2, because we saw, like, I mean, we just manually computed that a while ago and saw that magic2 did not have the same row sum on every row. So although we're not done with the check, even with what we've written so far, we should see that for magic1, it comes out true, and for magic2, it comes out false. So we should see that print. Let's go ahead and write the else case so that we can see it. And so say printf m is a magic square, magic constant, or however we talked about this, equals %d. And I guess I want line breaks on all of these. Oh, that reminds me. For whatever reason, when I malloc, I need to check that the malloc was successful. So let's go ahead and say if not matrix, then printf malloc fail, and let's exit 1, and this is going to come from magconst. I think that's right. Is there anything I'm missing? I need to return 0. But even by now, I think if I run it, and I run it on magic 1, I should see it say that it is a magic square, and if I run it on magic 2, I should see it say that it's not. So let's try it out. That worked, at least to compile. Let's do magic 1 is a magic square. Magic, ooh, that's not good. Oh, I never updated, ooh, no, I did update check. What's going on here? Check is initialized. Oh, right, because on the, well, oh, that's a bug. I should be updating check. Or no, wait, what is mag? Is mag is what I should be doing there. Okay, oops, that was a mistake. And build make, it is a magic constant, but now it is correctly reporting the magic constant 15. Okay, let's try it on magic 2. So that is that. Not a magic square, exactly what we should be seeing. So things are going well so far, even though I've only done the row check. Let's move on to the column check. The column check is going to be exactly the same thing, except reversing the order of row and column. So let's say for int j equal to 0, j less than, what was it, n, j plus plus. For int I equal to 0, I less than m, I plus plus. I want to say, oh, right, up above, check is 0. Check gets updated by matrix at I times n plus j. And then isMag gets anded with mag const equals check. Oop, forgot the I. Okay, so that's the column check. And let's go ahead and just make sure that everything's working out correctly. Let's debug. Can I run? Will it not let me run? I probably need to like download some kind of extensions to have better ability to run things. But let's just jump into here. So build, run, not a magic square, is a magic square, still working. Do I want to check other files while I'm at it? Let's go ahead and check 3. Why not? Is a magic square with magic constant 1 exactly the right thing? Let's try it with 4. Is a magic square with magic constant 260, and it's so big that I don't want to check it. I'm going to trust it. It would be nice to see a big one come out false just to know that it seems to distinguish between true and false. 7 is a non-magic square, and it's a big one. So that looks like a good sign to me. Okay, all right, I decide that things look pretty good so far. But I've only done the row check and now the column check. I still haven't done the diagonal check, so let's go ahead and do that. Now, it may be interesting. How do you progress along the diagonal in a for loop? Well, the answer, right, going from upper left to lower right probably is easier to think about, so let's start with that one. And you want to basically progress both the row index and the column index simultaneously. And you only need to do this once per row, right? Because every diagonal entry is only going to occur on a single row. So I only need the index I. And I can say check is set to 0. Do I want to do that? No, I don't. I want to do that up above. So check is set to 0. And then I want to increment check, or accumulate the values of the matrix. And these, right, in plus I is incrementing both the row by 1 each time I increments, and also incrementing the column by 1 each time I increment. So that is how you get the upper left to lower right diagonal. When I'm done, I'll say is mag anded with mag const equals check. And then let's do the off diagonal. In fact, I might as well, because I'm probably going to just need to use a single, right? Like, so we're going to go from bottom left to upper right. Let's think about that means that I am starting at index, row index, m minus 1. And then I would like it to progress up to 0. So let's say that I am going to, although in order to do this, I would need to reuse check. So maybe let's not do it in a single for loop, not that this super matters, but let's just say for int I equals 0, I less than m, I plus plus, check plus equals, matrix at. Now let's talk again about the coordinates. I want to start at m minus 1. So I'm going to go ahead and write that. Let's just start with m minus 1. And I would like to subtract, because, right, if I subtract I, then as I gets bigger, this index gets smaller. And this I want to be my row index, and the rows should start from the bottom left. So it's starting at m minus 1 and getting smaller and smaller and smaller until it reaches 0. As always, the row index should be times n. Plus, now the column index still increments simply by I. So that should be how you get the indices going from bottom left to top right. Okay, again, let's check. Is mag anded with mag const equals check. And that might be the whole thing. We might have the whole assignment done at this point. Let's compile. Let's execute. Not a magic square, still a good result. Let's check 1. Ooh, that's not good. 1 was supposed to be a magic square. Did something wrong. Oh, I think it's that I never zeroed out check after this thing. So check zeroed out. Now let's try it. Oh, crap. Magic 1 is a magic square. Back to being a magic square. Great result. 2, not a magic square. Great result. 3 is a magic square. Great result. Those are the only ones where the professor seems to have told us what the correct output is for these particular ones. So I guess we're going to have to just trust that it got the rest of them right. But that seems pretty good. All right, end of video. I think, right? Oh, no. Because I forgot to free my, how many things have I know I've made the matrix, so I should free the matrix and null the pointer. And what else? What else? Did I malloc anything else? I don't think so. I think I'd remember if I had. So I think we got it now, right? We returned 0 at the end. We freed whatever we malloced. I don't think there's any other pointer. So now I think we're good. Okay, there we go. I guess I'll just go ahead and compile, even though I'm sure that must be fine. Cool. All right, seems to work. Now we're done.